In lesson 1.1, we are going to solve equations with distributive property and combining like terms. In the warm-up, we are just going to review how to solve equations using opposite operations. The first thing we always should do in solving equations is draw a line down the equal sign and then get rid of anything that has been added or subtracted. To get rid of a plus 6, we are going to minus 6, and what we do on one side, we must do to the other. That will cancel out the positive and negative 6, leaving us with 2x is equal to 4. Then, to get rid of the multiply by 2, we divide by 2. A letter and a number that has been smushed together means multiply. The opposite of multiply is divide. Your final answer here would be x equals 2. On number 2, same thing. Draw a line down the equal sign and get rid of the minus 5 by plus 5 on both sides. What you do on one side, you must always do to the other. That's going to leave us with an x divided by 3 equals 22. Now, to get rid of divide by 3, we're going to times 3 because that's the opposite of divide. That leaves us with x is equal to 22 times 3 is 66. There are 2 ways to simplify equations before solving. Distribute and combine like terms. Part 1, we are going to simplify using the distributive property and then solve. Distribute involves multiplying a term to multiple terms within a parentheses. On this first one, the number that we are distributing is the 3. So I'm going to draw my line down my equal sign, and I'm going to distribute the 3 to both pieces of this equation. So both numbers inside are going to get multiplied by 3. 3 times x is 3x. 3 times 5 is 15. And now we're right back to what we were doing in our warm-up with solving. To get rid of plus, we minus. 3x is equal to 30. And then get rid of multiply by divide. X equals 10. On our next one, we're going to draw our line down our equal sign. You look for the number on the outside of the parentheses, and then you draw your arrows, your distribute, to the 2 numbers inside. 10 is the only thing on this side. Now, if we distribute, we've got a negative 4x times a 0.2. That's going to give us a negative 0.8x. And then negative 3 times 0.2 is negative 0.6. Decimals are no different than regular numbers. To get rid of a minus, we plus. We end up with a 10.6 is equal to a negative 0.8x. Again, to get rid of multiply, we divide. X is equal to negative 13.25. You can have negative 13.25 equals x or x equals, I just like to keep my variable on the left. And then this last one, again, no different with fractions, no different with decimals, no different with whole numbers. We do them all the same. Take the number on the outside and distribute it to the inside. 1.5 is equal to a negative 5 over 4x. We multiply these 2, we just set them side by side. And then negative 5 over 4 times negative 6 over 5 is going to give us a 1.5. Now, there are a variety of ways you can write decimals and fractions. If you don't like improper fractions, you could make this a negative 1 1/4. If you like decimals instead, you could make this a negative 1.25. Anything equivalent is fine. So again, if you don't like 1.5, make it 3 over 2. Make it 1 1/2. Make it whatever you're comfortable with. Fractions, decimals, improper fractions. Now, to get rid of plus, we minus. And you're going to notice that it cancels both times. Well, we can't leave emptiness over here, so we have 0 is equal to a negative 5 over 4x. And then to get rid of negative 5 over 4, since it's being multiplied, we divide. hopefully, you recall that 0 divided by anything is 0. Final answer. All right, down here at the bottom, we are going to investigate what like terms are. So we are going to use this problem, this expression, for all of these boxes down here. We're going to start by just answering some generic questions, starting with how many terms are in this expression. So if you look, we've got 1, 2, 3, 4, 5 terms. So a term is a number, a variable, or a number and a variable smashed together. So just a number, just a variable, or a number and a variable smashed together. This is a term, and this is also a term. So it can be any of those things. Coefficients. What are the coefficients? Coefficients are the number in front of a variable. So you got to go find your variables, and then you got to look at what's right in front of it. Well, there's a 3 for that one. Here's a variable. There's a -2 for that one. And then here's a variable, and it doesn't have a number in front of it. So you put the -1. Those are our coefficients. Coefficients are the numbers that are in front of the variables. Now, in contrast to that, constants. Constants are the plain numbers. They have no variables with them at all. So it's just a number. Which of these terms are just a number? 5 and 7. All right, so now, again, using this, we're going to go to which terms are like terms. So going through this, it looks like we have like terms with our -2x and our -1x. Our -2x and our -1x would go together because they are exactly alike. Our 5 and our 7, those are also like terms because they are also exactly alike. So to be like terms, they have to exactly match, okay? So it's terms whose variables and exponents are the same. I'm just going to put terms that look exactly the same. So I mentioned exponent. This has an x with it. This 3 definitely has an x, but this x has an exponent of a 2. This x does not have an exponent of 2. This x does not have an exponent of 2. So these two go together because they have the same exponent. There isn't one. Or technically there's an understood one. This one has an exponent of 2 and there are no other friends with it. So these like terms are essentially like BFFs. They gotta be exactly alike in all ways or they're not considered like. So now in this last part it says simplify the expression by combining like terms. So we're gonna start with this guy right here. He doesn't have any besties in this problem. There are no other terms that have an x squared, so we just copy down the 3x squared. Now, I already have underlined this in purple and this in purple. This -2x minus the 1x is going to give us a -3x. So you just do exactly what it says. If it says -2 minus 1, then that's what you type into your calculator. -2 minus 1. So you type in exactly the number and exactly the sign. Don't add any more, don't subtract any more. Do exactly what it says. And then we've got a 5 plus 7, which is 12. Combining like terms is when we just add or subtract. The coefficients. And we do that with the terms that look exactly alike. Okay, on the back, part 2, we are going to simplify by combining like terms. And then we're going to solve, just like we did on the front. Combining like terms mean we just add or subtract things that look exactly alike. So draw a line down the equal sign. And let's start by looking for like terms over here on the left-hand side. I always like to put a 1 with my letters that don't already have a number out front. So I've got a 1x minus a 4x. Again, 1 minus 4. You type it in exactly as it says. That's going to give us a negative 3x. I'm going to just drop my plus 10 because it doesn't have any like terms. And now we solve. How do you get rid of a plus? You minus. Negative 2 minus 10 is negative 12. And how do you get rid of multiply? You divide. So we're getting lots of practice solving here. Our final answer would be 4. Number 5, same thing. Draw a line down the equal sign. 6 is all by itself, so I'm just going to copy it down, and we're going to look for things that look alike. I would say this 3 and this negative 7 both have an x, so they look alike, so we're going to put them together. 3 minus 7, did I type that in right? 3 minus 7 is negative 4. There's a glare on it. The 6 doesn't have any friends, so I'm just going to plot my my plus 6 right there. Then, to get rid of a plus, we minus. Here again, we have that weird everything cancels thing, so we got to put something over here. That's a 0, is equal to a negative 4x. Some of you might already know the answer here, but let's go ahead and finish it. Divide. To get x is anything with a 0 on top is going to be 0. On number 6, we've got line down the equal sign, and then we're looking for like terms. To me, the negative 5 and the positive 10 look like they go together. They're just plain constants. Negative 5 plus 10 is just 5. And then we've got a 14x is equal to a negative 79. To get rid of a positive 5, we're going to minus 5. So we've got 14x equals a negative 79 minus 5. Again, whenever you're combining those, you do exactly what it says. Don't add any kind of symbols or signs. Just do what it says. Negative 79 minus 5. And then take the 14 with division. Final answer is negative 6. All right, now we're going to kind of put all of this together into some word problems, starting with number 7. It says that Mrs. Polly and Mrs. Adams went to Rally's to buy food. They bought 2 hamburgers and 2 orders of mozzarella sticks that each cost $2.50. The total cost of their order was $15.25. Write an equation to find the cost of each hamburger. So we don't know the price of the hamburger. So let's let H be our hamburger. That's going to be the variable that we choose here. We're going to start by buying 2 of those, 2 hamburgers, so 2H. Then we bought 2 mozzarella sticks. Well, the mozzarella sticks we know are $2.50, so plus 2 times our $2.50 mozzarella sticks. And then it says our total. Our food cost us $15.25. Now, some of you might have said, well, I know that 2 orders of mozzarella sticks at $2.50 is just $5. If you wanted to just jump straight to that, that's totally fine. So if you already knew that 2 times $2.50 is 5, that's great. But if you needed to write out that first step, there you have it. And now we just need to solve. On this one, though, it's asking us to just write an equation to find the hamburger cost. So if you wanted to just write this for this problem, I'm kind of going a little extra here, you could. If you wanted to write the one right underneath of it, you absolutely could. So those are both equivalent equations for this problem. I'm going to add that there is another way we could write this. We know that we're buying 2 hamburgers, and we know that we're buying 2 mozzarella sticks. So that 2 is consistent. We know that we're going to buy 2 hamburgers and mozzarella sticks. And that's going to equal our $15.25. So this could be a third way that we write that. So distributive property could essentially be applied to this problem because we're buying 2 hamburgers and 2 mozzarella sticks for $2.50. So All three of these are equivalent ways to write an equation to find the cost of the hamburgers. Sometimes it'll just ask you to write, sometimes it won't ask you to write and solve. Make sure you read those instructions. On number 8, again, we're just writing. It says that Zeke and Crosby went bowling. Zeke played 2 games and spent $5 on food. Crosby played 4 games. They spent a total of $20. How much did they pay for each game? So let's start with Zeke. Zeke played 2 games. So I'm going to use G for games because that's what we're trying to find. So 2 games. Then he went and bought some food. He's going to spend an additional $5 on food. Then his little brother wanted to play 4 games. So he added 4 games to their total. And again, the total was $20. If you want to leave it like that, totally fine. Hopefully you notice that there are some like terms here. 2G and 4G makes 6G plus 5 equals 20. So some of you might have looked at that and said, well, if Zeke's playing 2 games and Crosby's playing 4 games, they got to pay for 6 games plus their food to get the $20. Either one of these, totally fine. All right, last 2, we've got some shapes here. It says that if the perimeter of the trapezoid is 149, what is the value of x? Perimeter means add all sides. You will always be given the formulas on a formula sheet for Algebra 1, so you won't have to memorize formulas for Algebra 1, but you'll be doing a lot of application with geometry. So we're going to add up all of our sides. We're going to write down 2x plus 5x plus 7 plus 2x plus 3x minus 2. And we know that all of that is, which means equals, 149. Hopefully you see how this applies to our lesson today. Looks like geometry, but boy, there's a lot of combining like terms here. So let's draw a line down the equal sign and let's find our besties. We've got a 2x plus a 5x plus a 2x plus a 3x. 7, 8, 9, 10, 11, looks like 12 x's here. Then we've got our constants. We've got a 7 minus 2, which is 5. And that equals 149. To get rid of 5, we're going to minus. We've got 12x equals a 144. And then divide by 12 to get 12. The value of x is 12. All right, last one. If the perimeter of the square is 152 inches, find the value of x. So we, again, know that our answer is 152. We need to figure out what the value of x is. Well, they only give us one side. This side right here is 3x minus 7. Well, what we know, hopefully, about squares is that every single side is the same. And how many sides are there in a square? Obviously, there's 4 of them. So there's 4 3x minus 7s in this problem. And that's going to give us 152 as our answer once we do the math. Again, looks like geometry, but also looks like distributive property, which is what we're doing in this lesson. If we distribute, we get 12x minus 28 equals 152. Get rid of minus with plus. 12x equals a 180. And then divide by 12. 180 divided by 12 is 15. Final answer. Real quick note before we sign off. If you looked at this problem and said, I know that this side is 3x minus 7, and this side is 3x minus 7, and this side is 3x minus 7, and I want to write it out like I did this one. 3x minus 7 plus 3x minus 7 plus 3x minus 7 plus 3x minus 7 equals 152. And then solve by combining like terms, you would have gotten the exact same answer, and either way is acceptable in Algebra 1.